Hey, so what I'm going to talk about here is something super simple, kind of like a grade 6 sort of question. We're just adding fractions, so basic arithmetic. Um, and what we'll do here is we'll just take an example. So let's think about, I don't know why I spaced that out so far. Let's think about what happens when we add a half to a half. Okay, so I think this is relatively intuitive, relatively understandable. If we have, oh God, half of a pizza, let me just redo that actually. If we have half of a pizza or a pie, um, and then we added it to another half, so a half here and a half here, we'd end up with one whole, right? So we know the solution of this is one whole. If we then took 3/5 and added it to 1/5, so another scenario, let's say we take our pie and we split it into 5, so 1, 2, 3, 4. So 1, 2, 3, 4, 5. And we took 3 of them, so 1, 2, 3, and we added it to 1. How many would we have? We'd have 4 out of the 5. So those are fairly straightforward, nothing complicated there. Um, so how does this become difficult? How does this become difficult? Well, let's consider what happens when parts of our fraction are not the same. So let's say that we have something like 1 on 2 plus 1 on 3. Now I'm going to work down the page because that's how you should be working. Now, can I just add these? Can I just make it maybe 2 on 5? Does that work? 2 on 5? Question mark. Well, let's think about that. So let's say we had a half, right? We had a half, and then we want to add it to a third. How big's a third? How big is that? Well, a third is if you were to take a whole and split it up into 3 parts, right? So let's put one line there and one line there and one line there. And we'd have 1, 2, 3 equally sized parts. You're going to have to bear with me and pretend that's a perfect circle. Now, if we took, let's say, half and we added it to a third, how much of the circle do you think? So if you took half and added it to a third, what would that equal? Well, we'd have hmm, half of it colored in, but then we'd also have a third colored in, which is about this much. So we'd have all that colored in. So if we were to just think about it logically, we'd have most of it colored in. How about that? We'll just think about it like that. We'd have most of it colored in. Now, it's 2 out of 5 most. I mean, if I had 5 things, I only got 2 of them, or I only sold 2 of them, or I only got 2 out of 5 things, like 2 out of 5 marks in a test. I would not say that I got most of them correct. That would be an unfair statement. So we can logically see that this is probably not the solution to the question. Okay, so then how do we actually do something like this? There's a specific method. So the steps for it, I guess one step would be, actually I'm going to put those in blue so we can do our answer in green. Okay, so the first step would be make a common denominator. Make a common denominator. Now, if you don't know what a denominator is, that is the bottom part of the fraction. The fraction's made up of 2 parts. I think this has a name as well, but it's not really important. I'm not going to be referring to it much. Numerator, denominator. Okay, so we're going to make a common denominator, which means they have to be the same number. Currently, they're not, so that's a problem. So we'll make a common denominator. Once we do that, we have to adjust the numerators. And where was the numerators? Up the top. That's right. Adjust numerators. 3. Add numerators. Only the numerators. Okay. Let's follow these 3 steps and see where it gets us. See if it makes sense. Okay. So finding a common denominator is probably the hardest part in my opinion. That being said, it's not actually hard. So we have 2 and 3. A common thought to make these similar is to just add 1 to 2. But if you trial that with a couple of other fractions, you'll see that that doesn't really make any sense. So for example, if I was to just add 1 to 2, then I might get a 3 in the denominator, which would be nice. But then how would I change the top? Do I also add 1 to the top? Because that kind of makes sense. If I add 1 to the bottom, I'd add 1 to the top. Okay, let's consider that. So you get 2/3 as a result, right? But then if you add 2/3 to 1/3, we get a whole. We get 3/3, right? But we know, based on this down here, that it's going to be a lot of the pie or a lot of the pizza, but it's not going to be all of it. So that's clearly wrong as well. So that's not what we do. Okay, so we still have to make a common denominator. How? How do we do that? The way you do that is you look for a multiple of 2 that is also a multiple of 3. So multiple of 2, that might be 4. That's a multiple of 2. But is that a multiple of 3? No. Okay, how about 6? 6 is a multiple of 2, and it is a multiple of 3. So let's start with that. Start with 6. Okay, how did we change 2 to make it 6? We times by 3. And so whatever you do to the bottom, you must do to the top. So we get 3 at the top of this fraction instead. How do we change 3 to make it 6? We times by 2. So again, whatever you do to bottom, you do to the top. So you end up with a 2 up here. So that's this step done, making common denominator. That's this step done, adjusting the numerators. And the last part is adding the numerators. That's simple as 3 plus 2. You get 5/6. So fairly straightforward. Let's try another example just to make sure that we'll do it a little quicker, wrap our heads around it, make it a little different as well, just to see how people think about it. So let's consider 3/4 plus a half. Okay, so what's a common? So again, I would start with a smaller denominator, just because I find that generally to be easier. You tend to not miss the lowest common multiple by starting from the bottom. So start from the smaller denominator, which is 2, and just go up in multiples. So we'll go up. What's the next multiple of 2? It'd be 4, because you could double it. You get 4. Oh, that's the same as this. Perfect. So we know our lowest common denominator will be 4. How did we, we'll start left to right. How did we change 4 to get to 4? We didn't. So we don't do anything to the bottom. We don't do anything to the top. It stays as a 3. What about this? We times this by 2 to get to 4. So we times that by 2. So we get plus 2 from the numerator. The result of that is we get 5. And then the last step, so that's these 2 steps. The last step is to add numerators. So we get 5/4 as our answer. And we can think about that logically, right? How big is 3/4? 75%. Yeah, 3 out of 4. So it's a fair way through the pie. What about a half? Well, 1/2 is a half. It's exactly this much, right? So if I was to add this much to, I guess, this much, I would overflow, right? I would get more than a whole pie, which is what this is saying. This is 5/4, which would be 1 and a leftover quarter. Okay, so hopefully that helped people as well. I'll see you guys in the next video.